Welcome to creating React libraries from scratch. I'm Paulus, your instructor for this course. I spend my day writing full-stack applications and React libraries for critical infrastructure. An area I see engineers struggle with is how to share their React code. Rightly so, there's a lot of moving pieces to front-end development. I'm excited about this course to help narrow the gap between an empty directory and a fully managed React library in the Node package manager. In this course, we'll take a deep dive into creating a React library from scratch. We'll be implementing a library we're calling Scroller, an easy-to-use React website scroller. The implementation of Scroller will be minimal. We'll be spending this course learning how to create, publish, and maintain a React library. Though the code base has a focus on React, many of these same techniques could be used in a Node.js or JavaScript project. React is a framework developed by Facebook to make developing user interfaces easier. In the 2020 State of JavaScript survey, an annual survey conducted of front-end JavaScript community, React came in as the most used front-end framework. Due to React's popularity, writing libraries in it can expose you to a huge range of contributors and possibilities. This course is for the developer who wants to share the React code. Libraries are an excellent way of creating modular code that can be reused and shared between projects. As a code owner, writing a library can expose you to excellent contributors and learning opportunities. To get the most out of these lessons, you may want to be comfortable with front-end development. This means knowledge of JavaScript, how to use a terminal, and some knowledge of React is recommended but not required. Don't worry if you're not an expert in any of these areas though. Take a minute to refresh yourself with the React.js introductory tutorial and JavaScript fundamentals before continuing. Creating React libraries from scratch will be presented in 4 modules. In Module 1, we'll be setting up and installing dependencies for Scroller. Module 2 will be implementing Scroller and setting up Storybook. Module 3 will cover deploying it to the Node package manager. In the final module, we'll be looking at ways to improve our library and make it more maintainable. Throughout this course, we'll be working on a library we're calling Scroller. Scroller is a library to expose the ScrollTo API through React hooks. We'll be writing a small API surface for Scroller, so this course can focus on the tooling and techniques revolving around the front-end library. For support, join us on the Newline Discord channel. I look forward to hearing your questions and seeing what you build throughout this course. With that, let's get started. For this course, we'll need a few packages and tools installed on our computer. Throughout this course, I'll be using Windows, PowerShell, Firefox, and Visual Studio Code for development. All the packages we need can be installed on any operating system, but I'll be showing you how to install them using Windows. Refer to each package's website for information on how to install them on macOS or Linux. For this course, we will need Node.js and npm, which get installed together, Yarn, Git, a web browser like Chrome, Firefox, Edge, any modern web browser will work, a terminal like Bash or PowerShell, and a code editor, Visual Studio Code, Vim, Emacs, whatever you prefer. Node.js is a JavaScript runtime that allows us to execute JavaScript on a computer without a web browser. Out of the box, installing Node.js will also install npm, or the Node package manager. We'll be using these technologies heavily, so let's get them installed. Navigate to the Node.js website and download the latest long-term support or LTS installer for your operating system. If you prefer using a package manager, refer to Node.js's package manager documentation. Once installed, open a terminal and run node -v to check if Node is installed. This tells us the version of Node, and in my case, I'm using 14.16.0. Yarn is a package manager and a project manager. Think of Yarn as an extension to npm. In this course, we'll be using Yarn version 1, though much of the same workflows and commands will work in Yarn version 2. To install Yarn, run npm install -g yarn. Once everything's installed, run yarn -v to check your current version. I'll be using 1.22.10. Git is a very popular distributed version control system. We'll be using Git to allow multiple contributors to work on a code base and as a way to communicate with GitHub. To install Git, navigate to the Git website and click Download for your chosen operating system. We can check the version running git ---- version. Visual Studio Code has a lot of great extensions and auto-completion features. We'll be using it as our editor in this course. To download Visual Studio Code, go to the Visual Studio website and download it. All great JavaScript libraries start with a single command. In your favorite terminal, create a directory that will hold our project Scroller. In my case, I'm on desktop, and I'll create a new directory called Scroller, and then navigate inside that directory. We're going to run a command called yarn init. This will walk us through the initialization of a node package by setting up our package.json file. Package.json defines the metadata of our application, things like project version, name, dependencies, etc. Let's run yarn init. Yarn will first ask us the name of our package. In NPM, package names need to be unique, so let's prefix scroller with our username. In my case, it'll be ganders/scroller. We're fine using version 1.0.0, so hit enter to confirm. The description, we'll use easy to use scrolling library. Hit enter. Our entry point will be different than the default. The default is index.js, but we'll want our code living in source/index.js. We can ignore repository URL for now, so hit enter. Author will default to what we're logged in as, so hit enter. And then we'll use the MIT license for this course. Hit enter. Finally, it'll ask us if we want a package to be private. We don't, we want it to live on NPM and open to everyone, so hit enter. Our package.json file is now complete, and it's created. And we can look at it and see all the data we just entered. To make development easier, let's open Scroller in Visual Studio Code. To do this on the terminal, we can type code and then dot to open the current directory in Visual Studio Code. Next to the package.json file, let's create a new file called readme.md. This is a markdown file which will describe our project. Readmes are a great place to tell users how to install and use our library. We'll start out by just adding a description of what Scroller is. So let's go add a header called Scroller, and then just say an easy to use scrolling library. One of the first questions many users will ask themselves before using our library is, what is the license? The choice in licensing is a big deal. A software license tells consumers of our library what they're allowed to do with our code and what they're not allowed to do. It also describes any kind of liability or warranty we're responsible for as code authors. We could provide a license information in our readme.md file, but as convention, there's another file called license.md where we'll store a license. For references to various software licenses used, check out chooselicense.com. For Scroller, we'll be using an MIT license, which gives full open access to the code base while protecting us from any liabilities. Create a license.md file, and then paste the MIT information. In the top, we'll replace year with the current year and your name. We'll eventually want extra help in writing new features, fixing bugs, and maintaining their library. People would need to know how to contribute to Scroller and what kind of a community we expect. Create a contributing.md file to contain the same information. From here, we can give information on code standards, how pull requests and new code contributions are handled, the behavior we allow and don't allow in our community, roadmaps, and more. Anything a new developer would need to be able to contribute to the project will be on display in this file. We'll copy a contributing.md file from the internet and just use the basic template. Up to this point, we've been setting up documentation about our library. We need a folder structure that makes it easy for contributors to find where files are located. Each programming language has a different naming convention and folder structures. In JavaScript, a source or src directory contains all library code. Let's create this by creating a new folder called source. Finally, we can create our first JavaScript file. Inside source, create a file called index.js. We'll be using this file to export our public interfaces for users to consume. For now, we'll just export some test code, but in the future, we'll replace this with our Scroller library. Inside index.js, paste the following code. This code uses module exports, which is how Node.js exports modules using the common JS format. Don't worry, we'll be looking at module formats in more detail in the future. For now, this will allow Node.js application to include or require our code. We're exposing an object containing a function named hello, which will return hello world when called. This is a name export. In Node.js, we would require hello using the const hello equals required scroller syntax. Remember our package.json file? When we ran yarn init, we set our entry point to the project was source/index.js. We created the project structure source index.js, so whenever someone imports ganders/scroller, it would go to this file first to know what public interfaces are available. At this point, we have the scaffolding of our project complete, and we can continue on. The end goal of writing a library is having an application consume our code. In other words, our library would become a dependency in another project. In the same way as a project can depend on our library can also have its own dependencies. In NPM, there are three types of dependencies. There are dependencies we directly rely on, called dependencies. Dependencies we only need for development, called dev dependencies. And dependencies we expect users to provide for us, called pure dependencies. Our package.json file defines the three types of dependencies. We can use every type of dependency or none of them. There are no rule to the number of dependencies in a project. Let's take a look at an example package.json. When defining dependencies, we want to stick to a version or a range of versions we know will work with our library. Packages in NPM use semantic versioning. The semantic versioning standard communicates changes to a project. These version numbers are immutable or cannot change once they're published. Semantic versioning is defined as major.minor.patch. When the major number is bumped, there's a high probability of a break and change. For example, upgrading React from 15.0.0 to 16.0.0 is a major jump in features and deprecations. The consuming code is likely to break. Minor numbers are incremental changes. These could be new features, but break and changes are minimal. Lastly, patch numbers communicate bug fixes. There should be no break and changes. Now that version is cleared up, let's look at those symbols in front of the numbers. NPM has additional utilities to make handling dependencies easier. For example, the caret for Webpack tells NPM to use version 5.0.0, except if a newer minor or patch version exists. If version 5.0.1 had been published when we ran yarn, then version 5.0.1 would be installed instead of 5.0.0. These utility symbols are useful to reduce micromanaging dependencies, but gain a lot more power when used as pure dependencies. A full list of symbols can be found on the NPM documentation. Keep semantic version in mind when managing dependencies and publishing your own packages. Now let's dig a little bit deeper into each of these dependency types. Let's start with dependencies. The dependencies field in your package.json file defines the direct dependencies your project uses. These get bundled into your library with the code you wrote. Any code needed in production should be included in your dependencies. Development dependencies, or dev dependencies, are the tools and packages we use to develop our library. These don't get bundled into the final production build, so any dependencies needed for local development or testing belong here. Examples of dev dependencies include Webpack, Storybook, and testing frameworks. Both items in dependencies and dev dependencies get downloaded to your local machine when running yarn. Pure dependencies are dependencies that don't get bundled into a production build, but that we expect our users to include on their end. When running yarn, pure dependencies don't get installed on your local machine. So why are pure dependencies necessary? They allow us to reduce conflicts in the bundle size of the code, which uses our library. For example, if Scroller includes React as a dependency, and then the application uses Scroller, which has its own version of React, there would be two separate versions of React being initialized in the consuming application. This means we are including React twice, making users wait longer for applications to load. Having fundamental libraries like React and React DOM as pure dependencies make a lot of sense for a React library. For Scroller, we'll be using Yarn as a package manager, but there are many great ones out there like npm and pnpm, etc. By default, Yarn installs dependencies as project dependencies. If we want the dependency to be a dev dependency or pure dependency, then we must include additional arguments. So if we were to install React into Scroller, we would run yarn add React, and this would add React as a dependency. If we wanted React to be a dev dependency, we would use --dev or just -D. Then to install as pure dependencies, we would use --peer or $P. We can also install dependencies by updating our package.json manually. Anytime the package.json gets updated, run yarn to pull in the latest changes and new dependencies. In this case, if we made Webpack 5.0.1, we could then run yarn and pull in directly that package. Now we're ready to install dependencies for our library. We don't want to include React and React DOM in our package directly, but instead have whoever uses our library provide it themselves. In this case, we'll be installing React and React DOM as peer dependencies. In the same directory as package.json, run yarn add react DOM -- peer. Hit enter. As you can see, we don't need to run separate yarn add commands for each dependency. Yarn add takes single or multiple packages to install by separating the package names by whitespace. Next, we'll need to install any development dependencies we'll be using. This may seem weird, but bear with me. In the same directory as the package.json, run yarn add react and react DOM esbuild -- dev. Yes, we're installing React and React DOM twice, but not really. Remember in the last lesson when we talked about peer dependencies? These are libraries we expect the consumer of a library to provide, a contract. This means we won't be including or bundling React and React DOM in our library. So why did we install them as dev dependencies? Well, to be able to test the code we write as correct, we need a way of using React in the development setting. So we include React and React DOM as dev dependencies. Don't worry, both packages only get installed to the local disk once because dev dependencies don't get downloaded. Naturally, for a React library, we'll be needing React and React DOM. But what is esbuild? Esbuild is a code bundler, which means it takes care of creating a published build of a library. Esbuild will include any imported code, take care of building different module formats like ESM and CommonJS. Don't worry, we'll talk about these later, and provide optimizations like minification and dead code removal, or getting rid of code that's not being used. There are a few other bundlers available, including Webpack and Rollup. Webpack and Rollup are more generally used and support a wide range of functionality. esbuild is a new kid in the game. It's written entirely in the programming language Go, with a focus on speed. It's currently in the early stages of development, but esbuild has all the features we need for bundling our library. After running the yarn add command, you may find something odd in our project. We have a new file called yarn.lock. What does this do? Yarn.lock is a file that our package manager uses to ensure versions of the package don't change between installations. npm has a similar file called package.lock.json or shrinkwrap.json. A yarn.lock file contains things like a package hash or integrity that makes sure someone doesn't publish two separate instances of a package using the same version. It also stores the exact version of a package being used because we can define dependencies using version ranges, i.e. the caret or greater than less than sign. Yarn log is an important file to prevent dependencies from breaking our code. As such, this file should be included in source control, in other words, Git. Now that our project structure is set up for Scroller, wouldn't it be great if other people could see our code? For this course, we'll be using the source control software Git, which will be hosted on GitHub. Let's get started. So what is source control? Source control is a way of managing changes to code. It allows us to track the history of code changes. The most popular source control software is Git. Since Git is distributed, this means our code lives on a server somewhere else, and we perform changes locally on our computer. GitHub is a popular choice in being the server part of this. A distributed system allows for different collaborators to work in the same code base without changing code beneath each other's feet. Branches in Git are a way of encapsulating changes. There are many different branching strategies such as GitHub Flow and Git Flow. Each provide a framework on how to develop features, fix bugs, and release code. The most popular and open source in GitHub, of course, is the GitHub Flow branching model. The GitHub branching flow starts with a main branch, or master branch in older repositories. Any code in the main branch should be deployable, or in other terms, anything in main should be tested and functional. When a new feature or bug fix is being developed, a developer will create a branch from main, generally called feature / a description of the feature, or bug fix / description of the bug fix. Any code changes will be performed within this branch, committed, and then pushed to the main repository in GitHub. It is then a pull request is created into the main branch. A pull request is a chance for project owners, other developers, and automated scripts to review the code changes and mark them either as ready to merge or needs more work. Once everything looks good, our code is merged and applied to the main branch. Navigate to github.com. If you don't already have an account, create a new one. GitHub is a free and open repository for code. Once logged into GitHub, On the top of the screen, look for a plus icon and select New Repository. Here we can create a new repository that will hold Scroller. We'll need to give it a name. In our case, we'll just use Scroller. Next, we can give a description of our library. We'll say My Awesome Scrolling Library. We can ignore the rest of these options and go straight to Create Repository. Welcome to the home of our library. Let's get our code deployed on GitHub. Open a terminal and navigate to the Scroller project. We'll need to initialize Git in our project before we can connect to GitHub. Run git init to initialize a new Git project. Out of the box, Git will track all files that Git was initialized in. We don't want all our code being tracked by source control. Naturally, if a file can be recreated, we don't need to include it in source control. For example, this includes any build artifacts, dependencies, such as node modules, or debugging outputs. Better yet, having source control track files like this can cause Git to become slow and make merge conflicts more frequent. To prevent files and directories from being tracked by Git, we can create a file called .gitignore. .gitignore is a newline separated list of regex values that tells Git what to ignore. Create a .gitignore file at the root of Scroller. We'll add node modules to exclude any dependencies from Git, and our dist folder to exclude the final build from Git also. First, we'll add all the files to Git's staging area. In the Scroller directory, run the command git add -a. This is a shortcut to add everything. Next, create a commit or snapshot of the stage code by running git commit -m with some comment. -m lets us inline a git commit comment straight into the terminal. Here we'll just say my first commit. We'll set main to be the master branch by running git branch -m main. Navigate to the Scroller GitHub page we created and copy this git remote at origin line. This will tell Git to push any code to the GitHub page. Finally, to get the commit pushed to GitHub, run the command git push -u origin and then main, the name of our branch. In our GitHub page, refresh the screen and notice our code is now pushed up to GitHub.